Hello, this is Galo Romero, app developer for Biosensing 2.0, and this is our introductory video of the project. Our team members are Galo Romero and Jordan Lang. This system was produced with the thought of helping people with heart issues and other health-related concerns from mild to severe, people that visit the doctor very frequently and or require constant monitoring. Though it has the potential ability to connect to any device that uses BLE technology, it was primarily designed for use with a very small device that can be worn, like a wristwatch, and is currently in development. The system we designed allows the user to use an Android application to connect to a BLE biosensing device's sensor and read their data. Additionally, while the app is connected to a sensor, it will automatically store the current reading of that sensor in a database every 30 seconds. The user can also view real-time graphs of biosensor data and graphs with data in user-specified ranges in the app. There is no current system that meets these requirements, but a similar system already exists that was developed by Texas Instruments. They have an Android app called TI Simple Link, and it's designed to be used with the TI Simple Link sensor tag, a small device that collects weather measurements like temperatures and humidity. Although we did sometimes use a sensor tag to test our own Android app, it did not gather the types of data we needed and that would be useful to individuals and medical professionals. It also is not very user-friendly, nor does it store its data in a database, and the graphic displays are not very helpful. Over here we have some screenshots of our project, where you can see in the first screenshot, you can see once the app is connected to a BLE device, it will show the services and characteristics of it. You can also choose which graph you want to see, and once you select a graph, you will see the second picture, which is a dialog that lets you choose a range of dates. Once you choose the dates, you select Go, and in the third picture, you will see a graph displayed in the app. Here's our use case diagram. A user can scan for BLE devices, they can connect to a device, they can select a sensor, they can also select a sensor's graph, and then they can view that graph. The system design that we use is a multi-layer architecture. There are 3 layers which from front-end to back-end are the presentation layer, the logic layer, and the data layer. The presentation and logic layers together comprise the Android application, while the data layer is composed of the BLE biosensing device and the database server. The user only ever interacts with the presentation layer's UI, leaving the logic layer to retrieve and sort data from the biosensing device, as well as retrieve data from the database to be displayed to the user. Our system design is as follows. We have a biosensing device with different types of sensors that connects to our app through Bluetooth Low Energy. Then our app sends the data to a server where it's processed and then returned to our app to be shown as a graph. Here's a minimal crash diagram of our project. We have a main activity where it scans and lists BLE devices. Once you select a device, you are connected to it, and then you can choose to gather data and show a graph of the gathered data. Some of our user stories, some of our most important user stories are the ones that are shown here. Number 229, merge modules into finished app, was the most important. In User Story 229, integrating the two Android apps necessitated a lot of small and tedious changes, like to the Pages theme. Looking back, we should have implemented an SQLite database that was stored on the phone itself, and it would allow to use the app even without an internet connection. This is a sequence diagram for User Story 229, where a user can scan for nearby devices and find a list of devices, select the device they want to use, connect to it. Then they will display a list of sensors. The user can select which sensor they want to connect to, send that data to our database server. The user can then select a sensor graph, select the time and date they want to see of the graph, and pull that data from the server, and then the app will display a line graph. Here's a little short demonstration of our app where you can see how it all works out. Some of our test cases include the test case for User Story 229 on a sunny day. The purpose is to test if the mobile app can connect to a biosensing device sensor, store the data it collects in a server, and display graphs with data pulled from the server. Preconditions: the Android application package installed on a mobile device, the SQL server running on the same local network as the mobile device, a BLE biosensing device such as the TI sensor tag is nearby, and turn on. The expected result is the app connects to the device's temperature sensor and pushes the data to the server every 30 seconds. The app also displays a user-given range of temperature data in a line graph. Our actual result was the app was successfully connected to the TI sensor tag's temperature sensor and pushes temperature data to the server every 30 seconds. Also, the app successfully displays a line graph with the sensor's data within the range of date and times the user specifies. During a rainy day of User Story 199, which was to test what happens if the app correctly displays data from the unknown UIDs, we expected the app to display data in hexadecimal format, and the actual result was successful. The app actually displays the data in hexadecimal format. So in conclusion, biosensing is an app to aid in health monitoring for both individuals and professionals. Thank you for your time.